Hello, David Kenworthy here again, talking about the paper by Daniel F. Mansfield and N.J. Wildberger. Plimpton 322 is exact Babylonian sexagesimal trigonometry. Quote, perhaps this different and simpler way of thinking has the potential to unlock improvements in science, engineering and mathematics education today. And of course, as soon as these professors write this fabulous paper, there are articles being written in supposedly scientific journals trying to do down the findings of the professors. And that's what really got me interested in this paper, was the fact that it was so revolutionary. So let's get down to the nitty-gritty of what I suggested about this paper. I've said the professors have the number 1, but possibly the OB scribes had 1296000. It does seem that Plimpton 322 has been turned into something of a Rosetta Stone in respect of OB knowledge. Now what I'm saying is this line in the triplets can always be 1296000. And why that number's important is because of this book, Historical Metrology, written by Berriman, Algernon Berriman, in 1953, published by Dent Publishers. And Berriman has this fundamental value that he calls K, and it's 1.296 inches. And that is the root of all this ancient metrology, and he's called it K, and these are stated in K units, and we can see on the first line we've got 3400 K units. Now we know Thom's megalithic rod is 6.8 feet, and we've got 34 there, so this potentially reconciles to Thom's work. Now, if we look at what is actually happening here, we've got the opposite side is a variable and the adjacent side is a constant. And these numbers that the professors have worked out are decimal. And there's no way that the Babylonians would have known anything about decimal notation. And it's not something I'm really that keen on anyway, because it just hides everything. So that number is actually that divided by that. So we can see what's being hidden here. In all these numbers, we've got this number here, 1296000. We haven't lost the integrity of the Pythagorean triangles. So here on row 11, we've got 0.75, and we've got 972. These numbers are so important in ancient metrology. And when I summarised what I'd found, this is what I had to say. Interpreting Table 5. This must be said before anything else. Line 1, when converted to Berriman's K unit, is 3400 units, and this is base 17, being the base of the system discovered by Professor Alexander Thom in his book Megalithic Sites in Britain. He dropped a bombshell on Britain's archaeological academia, and the damage to it was astronomical. Again, we must refer to Berriman on page 14 of his book, quoting, "The quadrant chord arc length ratio is 9 to 10 if 22/7 is used for pi and 99/70 for root 2. In root 2 root 2 divided by pi. Both values were known in antiquity." Considering Berriman's Roman foot of 11.664 inches, table 3. 11.664 times 10/9 equals 12.96 times 10/9 equals 14.4. So 100 divided by 81 as 10/9 times 10/9 is being used here. Berriman suggests again on page 14. Accepting 2 root 2 divided by pi equals 10 over 9 as an equation leads to 20 root 2 equals 9 pi, and to pi squared equals 800 over 81. All these values can be used with negligible error in the analysis of metrological evidence. These values, when stated in decimal format, this is me talking now, tend towards 100 over 81, which equals 1.234567889. It's not exactly that, but I've put this just for effect because it's almost that. And 800 over 81 equals 9.87654321. That's actually a recurring decimal number, where 1.234567889 times 8 equals 9.87654321 with negligible error. Also, Babylonian pi is accepted as 3.125, and Egyptian pi is 256 over 81. Multiplied together, they give 9.87654321, which is 800 over 81, as we've already stated. It must be remembered that these decimal values were never understood by the users of the OB system. It must also be accepted that we are novices when it comes to understanding the subtlety and complexity of the OB system. The simplicity and beauty of it is for all to see in the simple use of one small wedge to create the whole of the numerical design as deciphered by the professors. But certainly the square root of 800 over 81 is pi is 3.142697, and well within the compass of Berriman's analysis as follows. 22 over 7 plus 22 over 7 times 9800 divided by 9801, I've put 0 in there by mistake, divided by 2 equals 3.142697. The factor here is 9800 divided by 9801 is 99 over 70 times 9800 divided by 9801 equals 140 divided by 99, the two versions of root 2 used by the OB in Berriman. So they were using two versions of root 2, and if you average them, you virtually get as close as possible as you can to root 2. And this is what they were doing. This is a system that they were using. There were 3 lines in their calculations. One was an upper limit for root 2 approximate. One was a lower limit for root 2 approximate. And the same applied to pi, from 22 over 7 as the upper limit to 22 over 7 times 9800 divided by 98 over 1 as the lower limit. And when you cross multiplied these numbers, the circle circumferences become the same. So you get the same circumference using 2 different versions of root 2 and 2 different versions of pi. Now to me, that's somewhere else. And because when you take the middle line, you're as close as possible as you can be to root 2, but not as close as possible as you can be to pi. But the pi version is a perfectly workable version of pi, and it didn't seem to bother them that they weren't looking for the exact version. I think they thought that belonged to somebody else. And just at the end here, I've done a reference to my book there. Something to ponder on, is the OB system sexagesimal or sexagesimal plus? The professors allude to this in their presentations. 60 is 2 times 3 times 2 times 5. 2 times 3 is 6 and 2 times 5 is 10. Professor Thom suggested base 10 was possibly universally sacred, and the Egyptian number for one god is 1,000,000. So there really is a lot to think about here. But most certainly, the only way to understand what the professors have produced is to reference it through the work of Algernon Berriman and Alexander Thom. That's it for now. Thank you.